Assalamu alaikum students. This is the time value of money lecture series part 3. So this is the third lecture from time value of money, right? So today we will in our last lecture we have seen I have shown you the derivation of perpetuity formula and growing perpetuity formula. So today we will do some examples for perpetuity and growing perpetuity, right? So let's solve this question. What we have in this question: XYZ Pharmaceuticals wants to issue a preferred stock in the market where they are offering a fixed dividend of 2 taka per share for an indefinite period, right? So that means if you buy that preferred share issued by this company, then you will get a fixed dividend of 2 taka per share for an indefinite period. So as we can see, dividend is fixed, that is 2 taka, and it will be given to you for an indefinite period. So indefinite period or infinite period. So if you see something like that, it has to be perpetuity. So if you get a fixed amount of cash flow for an infinite period or for an indefinite period, so this is perpetuity. Right. So the question is asking how much should you pay to buy this share if your required return from investment is 25%. So this required return from investment, that is the value of R or rate of return. So rate of return is 20%. The question is asking how much should you pay to buy this share. So that means how much should you pay today to buy this share. Right. So let me show you the timeline. Right, so if I draw the timeline, this is the timeline. So as you can see, this is period 0. So after first year you will get 2 taka. After second year you will also get 2 taka. After third year you will also get 2 taka, and like that way till infinite period. So that means, we want to find out the present values of all these future cash flows. That means we want to find out the equivalent amount that we should invest today, right? So that means we want to find out the present value of all these future cash flows today, that means at period 0, right? So we want to find out the present value, right? So as I said before, this is perpetuity. Why? Because you will get a fixed amount of cash flow for an infinite period. So this is perpetuity. So that means we want to find out the present value of all these future cash flows, that means present value of perpetuity at period 0, right? So present value of perpetuity. We know that the formula is C divided by R. So C is the cash flows. C is this fixed cash flows. So here C is 2 taka, and rate of return is 20%. Rate of return is 20%. Right. So rate of return is 20%. You need to use it in decimal, right? So 2 divided by 0.25, right? So 2 divided by 0.25, that means 8 taka. So 2 divided by 0.25, we will get 8 taka. So that means if you pay 8 taka per share, to buy this share today, that means if you pay 8 taka per share to buy this share today, then you will get this 2 taka per share at the end of each year till infinite period, and that will give you 25% return. That will give you 20% return per year. Right. So this is one good example for perpetuity, right? Now let's check out this problem. Let's go for this problem. Right. So what we have in this question: XYZ Pharmaceuticals wants to launch an IPO. IPO means initial public offering. When a company wants to issue primary share, wants to issue share in the market for the first time, they need to go for an IPO or initial public offering, right? So this company wants to launch an IPO in the stock market where they are offering 2 taka dividend at the end of first year. So that means at the end of first year you will get 2 taka dividend, and then from the second year dividend will grow by 10%. That means there and a 10% growth in dividends thereafter for an indefinite period. So that means at the end of first year you will get 2 taka dividend, but from the second year dividend will grow by 10%, and you will get 10% growth in dividend in all successive periods till infinity or till for an indefinite period. The question is asking how much should you pay, that means how much should you pay today to buy this share if your required return from investment is 25%, right? So how much should you pay today? That means how much should you pay today? That means you need to find out the present value of the share. You need to find out the present value of the share. So let's go for the time diagram. Right. So this is period 0, that means today. This is period 0 today. So at the end of first year, you will get 2 taka. So at the end of first year you will get 2 taka, but from second year it will no longer be. So in the second year, at the end of second year, it will no longer be 2 taka. Dividend will grow by 2%. So dividend will grow by 2%. So that means dividend will become 2 multiplied by 1 plus growth rate is 0.10. So that means we need to multiply it by 2 into 1.10. So 2 into 1.10, which means 2.20 taka, right? So that means at the end of second year you will get 2.20 taka dividend. So after 3 years, at the end of 3 years, dividend will again grow by 10%. That means 2.2 multiplied by 1.10. 10% is the growth rate. Growth rate is 10%. Growth rate is 10%. So in the question it said that growth rate is 10%. So in the question it said that growth rate is 10%. So you will get a 10% growth rate in dividends thereafter for an indefinite period. So growth rate is 10%, which means 2.2 multiplied by 1.10. So 2.2 multiplied by 1.1, that is we will get 2.42. So 2.42. So at the end of third year, we should get 2.42 taka. So like that way, dividend will grow till infinite period. So dividend will grow till infinite period. So that means this is, since infinite period is there, since infinite period you will get the cash flow till infinite period. So this is perpetuity. But growth rate is also there. Dividend will not gonna be fixed here. Dividend will grow by a fixed rate till infinite period. So this is growing perpetuity. So we want to find out the present value of all these future cash flows. So as I said before, so this is growing perpetuity. So that means we need to find out the present value of growing perpetuity. So present value of growing perpetuity. Present value of growing perpetuity. So present value of growing perpetuity formula is C divided by R minus G. C divided by R minus G. Remember, so this is the initial cash flow. This is the initial cash flow, and from the second period, dividend receive a 10% growth. So that means this is the first cash flow, and from the second period, dividend started receiving 10% growth, right? So that means, so this is the dividend, that is the first cash flow. So that means this is C. For us, this cash flow is the C. That means whatever that means the cash flow that hasn't received the growth. The cash flow that hasn't received the growth, that means the initial cash flow will gonna be the C, right? So C is here 2 taka. So C is here 2 taka, and rate of return, required return is 25%. Required return is 25%. Required return is 25%. So required return is 25%. That means rate of return is 25%. R is 0.25 minus growth rate. Growth rate is 10%. Growth rate is 10%, right? So growth rate is 10%. That means 0.10, right? So now if you calculate this one, you should get the answer. So 2 divided by, so here we get 0.25 minus 0.10, that means 0.15. So 2 divided by 0.15. So that means in that case we should get 13.3333 taka. So that means this has to be the fair price of the share. So that means if you buy this company's share at this price, so if you buy this company's share at this price today, in that case you will get a return of 25% per year. So that means you will get these cash flows till infinite period. You will get, so if you buy this share at the price of this taka today, in that case you will receive these cash flows till infinite period, which will give you 25% return per year. So this is one good example for perpetuity. So this is one good example for, right? So now we will study annuity. So what is annuity? An annuity is a series of periodic payments usually made in equal amounts, right? So annuity means multiple payments. So series of periodic payments. For example, if your mom is depositing 500 taka at the end of each month for 10 years, this is annuity. That means if your mom is depositing 500 taka at the end of every month, and so that means at the end of every month means, so she is depositing 500 taka at the end of first month, she is depositing 500 taka at the end of second month, and like that way she will deposit 12 installment of 500 taka every year. So and like that way in 10 years she will make total 120 payments or 120 installment of 500 taka each. So in that case, so here we have periodic payments. So periodic payments means here she is making monthly payments, and amount is also fixed, 500 taka. So in that case we will call it annuity. So that means an annuity means a series of periodic payments. So it can be monthly payment, it can be daily payment, it can be semi-annual payment, it can be quarterly payment, it can be annual payment as well. So that means if you have multiple payments paid or received at equal interval period, in that case we will call it annuity, right? So there are different kinds of annuities. Right? So what is annuity certain? An annuity that begins and ends on designated dates is called annuity certain. That is loan transaction, rent payments. So that means this kind of annuity will begin on a specific date, and it will also end on a specific date. So that means if you want to buy a car today, on a 5 years loan, so that means if you borrow, so for example, if you borrow 10 lakh taka or 1 million taka today to buy a car, and the loan will get matured after 5 years. So that means after exactly 5 years, the annuity will mature. So that means this is an example of annuity. Why? Because you have borrowed 1 million taka on a 5 years loan, by 5 years loan agreement, and you have decided to pay off the loan by making monthly payment, by making monthly installment. So since you are making multiple payments, so this is annuity. So that means since you are making monthly payment at the end of each month till 5 years to pay off the loan, so this is annuity, and we will also call it annuity certain, because this annuity will begin today and it will end after 5 years. So this is annuity certain. Now let's check out what is simple annuity. So let's check out what is simple annuity. An annuity whose payment intervals coincide with the interest interval is called simple annuity. So which means, for example, the example that I have given you before. So you have borrowed, if you have borrowed 1 million taka today, if you have borrowed 1 million taka today on a 5 years loan agreement, and you have decided to pay off the loan, by making monthly installment. So in that case, if the interest rate is also compounded on a monthly basis, so that means since you are making monthly payment and interest will also be compounded on a monthly basis, in that case this is simple annuity. But if you are making monthly payment, but interest will be compounded on a daily basis or on a quarterly basis or semi-annual basis, in that case this will not gonna be simple annuity, these will be complex annuities. So that means I'm saying again, if the payment interval, that means you will gonna make monthly payment, and interest will be compounded on a monthly basis. So if the payment interval and also compounding interval is same, in that case this is simple annuity, right? So if you are making quarterly payment and interest will also be compounded on a quarterly basis, this is simple annuity. But otherwise it will be called complex annuity. That means if you are making quarterly payment but interest will be compounded on a semi-annual basis or monthly basis or daily basis, so here if the payment interval and the compounding interval compounding interval does not match, in that case these will no longer be a simple annuity, these will be considered as complex annuity. So ordinary annuity. What is ordinary annuity? An annuity whose payment is made at the end of each payment interval. That's called ordinary annuity. So which means, for example, if you are making your each payment at the end of each month or at the end of each quarter, in that case this is ordinary annuity. So that means I'm repeating again, if you are making your each payment at the end of each payment interval, like if you are making your payment at the end of each month or at the end of each quarter, in that case we will consider it ordinary annuity, right? But if you are making at the beginning of the period, if you are making your payments at the beginning of the period, in that case it will be called annuity due. So if you are making your payment, right, so if you are making your each payment at the beginning of the period, in that case it will be called annuity due. For example, if you if you purchase a mobile on a equal monthly installment plan, that is EMI plan. So if you buy a mobile or any kind of other products on an EMI plan, in that case, and if you have to pay the first installment, on the day of purchase, so that means, for example, if you want to purchase a mobile today on an EMI plan, and you have to pay the monthly, you have to pay it off on a monthly installment basis. That means if you need to pay the first monthly installment today, in that case it will be considered as annuity due. So let me show you with a timeline. For example, you want to buy a car on a 5 years loan, and you want to pay off the loan on a monthly installment basis. So if you have borrowed, for example, you have borrowed 1 million taka. You have borrowed 1 million taka today to buy a car. So you have borrowed 1 million taka today to buy a car, and you will pay off the loan on a monthly installment basis. So if you have to pay after 1 month, if you have to pay the first installment, after 1 month, we will call it ordinary annuity. But if you need to pay the first installment today, so that means you are getting the loan today, and also if you have to pay the first installment today, in that case we will call it annuity due, right? So suppose you need to pay C amount of cash flow, or C is the monthly installment. Suppose C is the monthly installment that you need to pay after 1 month, and after 2 months you also need to pay C amount of cash flow. After 3 months you also need to pay C amount of cash flow. So after 3 months you need to pay C amount of cash flow. So after 4 months also you need to pay C amount of cash flow. So like that way, loan maturity is 5 years. If the loan maturity is 5 years, in that case, so in 1 year you will need to pay 12 installment. So in 1 year we have 12 months, so that means in 1 year you need to pay 12 installments, right? So in 5 years you will need to pay 5 multiplied by 12, that is 60 installments. So that is 60 installments or 60 payments, So 60 installments or 60 payments, right? So this is the 60 is the last period. So that means you need to pay equal amount of cash flow. That's why it is called equal monthly installment. So you need to pay equal installment amount till infinite period. So that means these are the total cash, all the future cash flows. So that means 60 cash flows are there. Right? So remember, the present value of all this future cash flow should be 1 million taka. Present value of all these future cash flows should be, present values of all these future installments should be 1 million taka. This is the present value. So this should be the present value. Right? So as you already know that this is, you need to pay equal amount of cash flow till 5 years. So a fixed period is there. So you need to pay a fixed amount of cash flow till 5 years. So that means here multiple payments are there. So periodic payments. So that means periodic payments are there. So this is monthly payments or periodic payment is there. So this is annuity. And since you are making each payment at the end of the period. So at the end of first month you are making your first payment, at the end of second month you are making your second payment. Since you are making your payments at the end of each month, so this is ordinary annuity, right? So the present value of these annuities 1 million taka. So what is the formula? So formula for present value of annuity. So present value of annuity So present value of annuity. So what is the, let's see what is the formula for present value of annuity. Right. So how I remember this formula? How I remember this formula? So present value of annuity, I remember it like this way. So present value of perpetuity, present value of perpetuity 1, present value of perpetuity 1 present value of perpetuity 1 minus present value of perpetuity 1 present value of perpetuity 2. So present value of perpetuity 2 starts at period T. So that means here we will, so to find out the present value of annuity, we need to take two perpetuities. The first perpetuity 1 will start today, and there will be another perpetuity that will start after period T years. So after period T years, at period T years. So that means this is second perpetuity that will start at period T. So we know that the present value of perpetuity is C divided by R. This is the present value of perpetuity formula. This is the present value of perpetuity formula, and we will have another perpetuity. This perpetuity will start at period T. So that means this perpetuity will start at period T. That means we will get the value of this perpetuity at period T. But we need to bring that value of that perpetuity today. So to bring it, we already know that this is the amount that you will get at period T. This is the value of this perpetuity that you will get at period T. So you need to bring that value of that perpetuity today. So to bring that perpetuity at period today, you need to find out the present value of that amount. Right. So this is the formula. I will show you the detailed derivation of this annuity formula at the end at my lecture series 4 or my lecture series 5. That means I will show you the derivation of annuity formula at my last part of this lecture series. So if you take C by R common, in that case we will have 1 minus 1 plus R power minus T. So minus T. Right. So this is the present value of annuity formula. So this is the present value of annuity formula. Right. So this is the present value of annuity formula. So now let's check out what should be the future value of annuity formula then. Future value of annuity formula. So future value of annuity formula. So if you remember just one formula, you can write the other formula. So it will be just reverse. So this portion will come first without the minus in the power. Since always remember, present value means we are going behind. So since you are going behind power, there should be a minus in the power. Again, future value, if you want to find out the future value, that means since you are going forward, power should always be positive, right? So 1 plus R power T minus 1 will be deducted, so minus 1. So if you can see here 1 was, we write 1 first and from that we have deducted this part. But when you want to write the future value formula, this part will come first without the minus in the power, and this one will go after minus. So this is the future value of annuity formula. This is the present value of annuity formula. Right. So now let's do some examples. Right. So let's do this example. So what we have in this example, if $100 is deposited in an account at the end of every quarter for the next 5 years. So that means if you check the keywords here, so if $100 is deposited in an account at the end of every quarter, so that means at the end of every quarter you are making your $100 payment. So that means in a year we have 4 quarters. So in 1 year we have 4 quarters. So that means in 1 year you are making 4 installments or 4 payments of $100 each. So that means multiple payments are there. So definitely annuity, right? And also if you can see at the end of, so that means this is ordinary annuity. That means you are making the payment at the end of each quarter or each payment interval period. So this is ordinary annuity, and since you are making multiple payments every quarter, so multiple payments, so that means at the end of first quarter you will pay $100, at the end of second quarter you will pay $100, and like that way in 1 year you need to pay 4 installments, and in 5 years you will gonna make total 20 installments. So in 1 year we have 4 quarters, in 5 year we will have total 20 quarters. So in 5 year you need to pay total 20 installments of $100 each. So the question is asking how much will be in the account at the time of the final deposit, right? So how much will be in the account at the time of the final deposit? Remember that final deposit will be made after 5 years. So definitely the final deposit will be made after 5 years. So you want to know after 5 years how much will be in the account. So you want to know how much will be in the account at the time of final deposit. That means after 5 years how much will be in the account. So if I show you the time diagram again, so this is period 0. So at the end of first quarter you are making $100 payment. At the end of second quarter again you are making $100 payment, and like that way up to 20 quarters. In 5 years we have total 20 quarters. In 5 years we have total, so in 5 years we have 20 quarters. So in 5 years we have 20 quarters, that means 20 payments. So 20 payments or installments of $100 each. So 20 payments of $100 each. Now the question is asking what will be in the account, what will be in the account at the time of final deposit. This is the final deposit. So how much will be in the account at the time of final deposit. So that means we want to know that how much will be in the account at this period, right? So that means we need to find out the future value, and as you already know this is annuity because we have multiple payments of $100 each, right? So we need to find out the future value of this annuity, right? So what is the future value of annuity formula? So we already know. So future value of annuity formula is F is equal to So F is equal to C divided by R. So C divided by R bracket 1 plus R power T power t minus 1 minus 1. So this is the future value of annuity formula. This is the future value of annuity formula. Here C is the installment amount or periodic payment amount. So C is the periodic payment amount. So here $100 is the installments. So C is $100. C is the installment amount or periodic payment amount. So C is $100. So C is $100. So if you put the values there, C is $100 divided by R. So here interest rate is 8% compounded quarterly. So interest rate is 8% compounded quarterly. So 8% means 8% is the, remember, 8% is the annual rate. So 8% is the annual percentage rate or APR. So that means 8% is the annual rate, but since the interest will be compounded on a quarterly basis, we need to find out the quarterly interest rate. So we already know in 1 year we have 4 quarters. So that means this is the 1 year interest rate, yearly interest rate. So if you want to find out the quarterly interest rate, we will divide it by 4. We will divide this one by 4. So if you divide this one by 4, what we will get? So 0.08, that's the yearly rate. If you divide it by 4, you will get the interest rate, right? Bracket, and then 1 plus R. So this is the value of R. So this is the value of R, bracket close, minus, sorry, not minus. So here power. So power, we need to give a power. So power T. So T is the periods. So T means periods, or how many installments are there, how many installments are there. So here we have total 20 installments. So here we have 5 years. So 5 multiplied by 4. In 1 year we have 4 installments. So in 5 year we have total, in 1 year we have 4 installments. So in 5 years we have total 20 installments. So we can directly write 20 here. So power is 20, and then we have minus 1, bracket close. So if you calculate these one, so I'm going to show you how you should calculate these one. Now I'm going to show you how you, right? So we can use this calculator. We can use this Android app. This is the Android app I have shared with you. So we can use this calculator, or if you have this calculator also, this is actually this Android app. This Android app is the Android app version of this calculator. So let me show you this how you can do this calculation using this calculator. So here what you have to do, so this is the, as you can see, this is the, there is a fraction icon is there. Here this is the fraction icon. So if you press this button, you will get a fraction there. You will get a fraction there. So we have, in the numerator we have 100. So 100. So and then this is touchpad. So if you want to, we want to type it here now. We want to type it here now in the denominator. So in the lower part of the fraction we want to type. So what you can do, you can press this button. You can press this button to go to the lower part of the fraction, or you can press this button as well. So if I press this button, so cursor is in the lower part of the fraction. So in the lower part of the fraction, another fraction is there. In the lower part of the fraction, another fraction is there. So we need to get another fraction there. So if you want to get another fraction there, you can press this button. You can press this button to get another fraction. So let me press this one. So another fraction is there. Right. So here we will have 0.08, and then again we want to go to the lower part of the fraction. So again you can use this arrow button. You can use these arrow buttons to go like that. So the cursor is there, and then 4. we'll press 4. And now what you can do, you can come out of the lower part of the fraction. So that means you can just touch there. So that means now the cursor, we need the cursor there. So I just touched it there, or you can use these arrow buttons also to go there. And then we will get a bracket. We will get a bracket. So as you can see, this bracket is for this one. This bracket is for this one. And then again, inside this bracket we have another bracket. So inside this bracket we have another bracket. So we need to get another bracket there. So I get another bracket there. And then we can press 1 plus, again we can get a fraction 0.08 divided by 4, bracket close. So you can type it like that way. And the power button. And now we need to get the power button. So this is the power button. This is the power button. So if you press this button, and now you can press 20. So now again we need to come out of the power. So we can just press this button. So the cursor came out from the power, and now we will press -1. Now we can press -1 and we can close the bracket. So as you can see, the answer, we already got the answer. So the answer is $2,429.7369. So you need to get up to 4 decimal point. So the answer is $2,429.7369. Okay, so this is the answer. So the answer is $2,429.7369. So this is the answer. Right. So now if you want to find out, if the question asks you that what is the present value, if the question asks you that what is the present value, if the question asks you that what is the present value of this annuity, what is the present value? So if the question asks you what is the present value, that means if you want to get, for example, you want to set up a pension fund. And you want to get $100 at the end of each quarter for up to 5 years. So that means, for example, you want to set up a pension fund where you want to get $100 at the end of each quarter, and you want to get it up to 5 years. So that means in that case, if the question asks you that what should be the present value, so what is the present value? That means, so what should be the present value of all these cash flow, future cash flows? So now the question is asking, this is another question. This question is asking what should be the present value of all these future cash flows. That means annuity. So this is annuity, there is no doubt about that. This is ordinary annuity. So that means, so we need to find out the present value of this annuity. Right. So present value of annuity formula we already know. So present value of annuity formula is P is equal to C by R will be same here. So here also we will have C by R. And then this one will come first. So first we need to take 1, then minus, and these one, and then these one with a minus in the power. Remember, so present value formula should always have a minus in the power. So now we can calculate these ones. So obviously these will be same like here. These will be same here. And then what we will have is 1 minus, and then we will get this one. Only thing that we need to change is in the power we need to get a minus. So in the power we need to get a minus. So we can calculate these one now. We can calculate these one now. So like before, we can type it in our calculator. So we can use it in our calculator. We can directly do it using our scientific calculator. So let me show you how I do it. First we need to get a fraction 100, and then we will get another fraction in the denominator. We will get another fraction in the denominator or lower part of the fraction. So first of all, I am showing again. First I got a fraction. And then I will press 100. I'll go in the denominator. So I'll go in the lower part of the fraction, and then I will get another fraction there, because so we have a fraction in the lower part of the fraction. So I will get another fraction there. So this is the fraction button. This is the fraction button. This is the fraction button. Right. So in the lower part of the fraction we will have this one. Right. So I have already typed it. Now I will get a bracket there. So remember, so I need to get first these one. I need to get first these ones, right? So I will get a bracket. So I will get a bracket like that. And then I will press 1 minus. So 1 minus, and then 1 minus, and then we have 1 minus, and then we have what? We need to get another bracket. There. So bracket, and then plus, and then another fraction 0.08 divided by 4, bracket close, power minus 20, bracket close there. So that means 100 right. So this way we should type it. So we should type it this way. If you type it this way, you should get the answer. If you type it this way, if you practice it at home, you can become expert on typing this. So once you become expert on typing this, you can get the answer very quickly. You can get the answer directly, and very accurate result also. So the answer is $1,635.1433. So the answer is $1,635.1433. Right. So that's the answer. So now let us practice one example. So if $100 is deposited in an account each month for 10 years, and the account earns 7% compounded monthly, how much will be in the account after the last deposit is made? So if $100 is deposited in an account each month, so if you pay attention, so $100 will be deposited in an account each month. So that means in 1 year you will gonna make 12 payments of $100 each. So in 10 years you need to make total 120 payments of, or 120 installments of $100 each. So multiple payments, that means annuity each month. That means you will gonna make the payment each month. So in 1 year you will make 12 payments of $100. So in 10 years you will gonna make 120 payments of $100 each. So this is annuity. There is no doubt about that. But the question doesn't give us any information that whether the payment will be made at the beginning of the month or end of the month. So question doesn't say that whether the payment will be made at the beginning of the month or at the end of the month. So if it doesn't say like that, if it doesn't say anything like that, by default we will assume that payment will be made at the end of the month. So that means by default we will assume that this is ordinary annuity. So interest rate is given 7% compounded monthly. Question is asking how much will be in the account after the last deposit is made. So how much will be in the account after the last deposit is made. So let me show you the diagram again. Let me show you the diagram. This is the time diagram or timeline. So today is period 0, right? So at the end of first month, you will make $100 payment. At the end of second month, you will gonna make $100 payment. So at the end of third month also, you will gonna make $100 payment, and like that way up to 10 years. So up to 10 years. So you will gonna make the payment up to 10 years. So 10 years means we in 1 year we will gonna make 12 payments. So total 120 installment or payments. So 120 payments or installments. So these are the installment amounts. So this is C. These are the installment amounts. So this is C. So last payment is at the period of 120. So these 120 payments. So last payment will be after 120 months. So last payment will be after 120 months. So $100. So that means you will make equal amount of payment of $100 each at the end of each month up to 10 years. So total 120 payments. So the question is asking how much will be in the account after the last deposit is made. So this is the last deposit. This is the last deposit. Now the question is asking what will be in the account at this period. What will be in the account? So that means obviously we want to find out the future values. That means we need to use future value of annuity formula, because we need to find out the future value of all these payments at this period, right, after 10 years. So we need to use future value of annuity formula. So as you already know, the future value of annuity formula is equal to, so F is equal to C divided by R bracket and then another bracket 1 plus R bracket power T minus 1 bracket close, right? So now we can put the value there. So C is installment amount or payment amount is $100. So payment amount is $100 divided by R. So interest rate is 7% compounded monthly. So 7% is the annual rate. 7% is the annual rate. So that means, but it will be compounded on a monthly basis. So 7% is the annual rate, but it will be compounded on a monthly basis. So that means we need to find out the monthly rate. So that means we need to find out the monthly rate. So 7% means 0.07 divided by, so this is the annual rate. If you want to convert it to monthly rate, in 1 year we have 12 months. So we will divide it by 12, right? And then bracket and then this one. So 1 plus R, that means R is this one. R is this one, bracket close, power T. So power T. So T is equal to what? So as you already know, in 10 years, so in 10 years we will have 120 payments or 120 installments. So power will be 120. Power will be 120 minus 1, bracket close. So as I have shown you before, if you type it like that way, exactly like that way, you should get the answer. So let me show you how you should type it. So first of all, we will get a fraction. Like that. And then we will press 100 in the numerator and then we will go to the lower part of the fraction. And then in the lower part of the fraction you should get another fraction there. So you will press the fraction button. So you will press the fraction button there. So you will press the fraction button there. So you will press the fraction button now to get another fraction there. So I got another fraction there. I got another fraction there. So 0.07 and then divided by 12. So 0.07 divided by 12, right? So we need to come out of the fraction. So I need to type it here actually. I need to type it here actually. So that means I will touch it there so that the cursor should go there. So that the cursor should go there. And then I will get a bracket. So then I will get a bracket. This is the bracket I got. This is the bracket I got for this one. For this one. And inside that we have another bracket. So I should get another bracket. So I should get another bracket. So I should get another bracket. And then what we have 1 plus and then 1 plus, that means and 1 plus, and after that we need to get another fraction there. So we should get another fraction there. 1 plus another fraction, 1 plus another fraction, 0.07 divided by 12. Bracket close. Bracket close and then power button. So this is the power button. This is the power button. So this is the power button. Power 120 minus 1. Bracket close. So power 120 minus 1, bracket close. Right. So we got the answer. So this is the answer. This way you should type it. You should type it this way to get the answer directly. So if you practice more and more at your home, you can do this calculation very quickly and directly. Right. So this is the answer. So the answer is this one. 17,308.4807 dollar. $4807. So this is the answer. Right. So now let us solve this question. How much should be deposited in an account? So how much should be deposited in an account? So how much should be deposited? How much should be deposited in an account at the end of each quarter? So how much should be deposited in an account at the end of each quarter? So that means at the end of each quarter. So at the end of each quarter. So not single quarter, multiple quarters are there. So that means at the end of every quarter, at the end of each quarter you need to make some payment. So in 1 year you will gonna make 4 payments, so 4 installments, and in 5 years you will gonna make total 20 installment or 20 payments. So question is asking how much should be deposited in an account at the end of each quarter for 5 years. So that means how much you should deposit at the end of each quarter. So what should be the installment amount? That means what should be how much should you deposit at the end of first quarter, how much should you deposit at the end of second quarter, and like that way. That means you need to find out the quarterly payments or quarterly installments to accumulate $10,000. So accumulate means we need to get this amount after 5 years. Accumulate means we need to get this $10,000 after 5 years. Interest rate is given. So let me show you in this one by drawing timeline. So the timeline will be, so this is the timeline. So at the end of, so for example, at the end of first quarter you will gonna deposit C amount, because we don't know how much you will deposit at the end of each quarter. At the end of second quarter you will gonna deposit again C amount. At the end of third quarter you will gonna deposit again C amount, and like that way up to 5 years. Up to 5 years. So up to 5 years means in 1 year we will have total 4 quarters. In 1 year we will have total 4 quarters. So that means in 5 years we will gonna have total 40 quarters. 40 quarters. So that means 20 quarters. So in 5 years we will gonna have total 20 quarters. So that means 20 is the last period. So 20 quarter is the last period. So that means we will gonna make equal payments. So question is asking what will be the value of C. That means what will be the value of quarterly payments. So that means at the end of each quarter how much should you deposit. So that means what should be the value of C. So that means we need to find out the value of C, quarterly installments. So to accumulate what? To accumulate future value. So how much we will need? So that means the future value of all this cash flow, future value of all these cash flows are given. So after 5 years we need $10,000. So we need $10,000 from the account. So after 5 years we will need $10,000 from the account. So which means future value of these all cash flows should be $10,000. So future value of all these cash flows, future values of all these cash flows should be $10,000. So as you already know, this is annuity. This is annuity and we need to find out the value of C. So future value of annuity is given. Future value of annuity is there, right? Since the future value of annuity we know, we should use the future value formula. So since the future value of annuity we know, we should use the future value of annuity formula. So future value of annuity formula is what? This is the future value of annuity formula. Right. So this is the future value of annuity formula. Right. So future value of annuity is given. We need to find out the value of C. So if you do cross multiplication, in that case we will gonna have F into R. That means this F will be multiplied by this R if you do cross multiplication, and then in the right hand side we will be left with this one. So in the right hand side we will be left with this one. Now future value of annuity. So future value of annuity, that means future value of these annuity, should be $10,000. So we want to accumulate, or we want to get $10,000 after 5 years by saving at the end of each quarter. So future value of annuity is $10,000 given in the question, multiplied by R. R is what? 8%. 8% is the annual rate. 8% is the annual rate. So 0.08 is the annual rate. So but this is the annual rate, but it will be compounded on a quarterly basis, which means in 1 year we have 4 quarters. So that means to find out the quarterly rate we need to divide it by 4. So we need to divide it by 4 is equal to, we don't know the value of C. So 1 plus, this is the value of R. We could directly write here 0.02 as well. No problem with that. Power T. So power T is equal to what? T is 20 payments. In 1 year we have 4 quarters. So in 5 years we have total 20 quarters. In 5 years we have total 20 quarters. So power will be 20 minus 1. So let's do it. First of all we will multiply these two. So first of all we will multiply these two. So what we can do? So if you want to multiply these two, what you can do? First you can press 10,000 multiplied by, then you can get a fraction like that. Then 0.08. So if you press it like that way, If you place it like that way, you should get 200. So if you place it, so if you place it like that way, you should get 200. 200 is the answer, right? So you should get 200. That means multiplication of these one is 200 is equal to C multiplied by, you can type these one also exactly like that way. So you can type it also exactly like that way. So bracket 1 plus 0.08 divided by 4 bracket close power 20 and then minus 1 and then minus 1. So we can also do it like this way. So we can also do it like this way. So if you type it like this, you will get the answer. So 0.4859. So you need to take up to 4 decimal point. So the answer is 0.4859. So here if you solve this part, so we will get 0.4859. Right. So C will be what then? C will be is equal to 200 divided by, so C will be 200 divided by this one, so 200 divided by this one. So if you calculate it, so 200, so 200 divided by, you can press the answer button, because that was in the, so that means whatever you get, so that means whatever we get from this calculation, so it is already in the answer, so we can just press the answer button. So if you press the answer button, so answer will be what? 411.5671 from 5671, right? So that means if you deposit $411.5671 at the end of each quarter, and like that way up to 5 years, you can easily get $10,000 from the account after 5 years. So that means you can easily get $10,000, you can easily accumulate $10,000 after 5 years from the account. Right. So now let us solve this question. A company wants to accumulate $1 lakh, so $100,000 to purchase replacement machinery 8 years from now. So a company wants to accumulate, that means a company wants to get $100,000 to purchase replacement machinery 8 years from now. So that means they need this amount of money 8 years from now, that means after 8 years. To accomplish this, equal semi-annual payments are made to a fund that earns semi-annual 7% compounded semi-annually. That means to save this amount they will need after 8 years. To save this amount, what they are doing, they are making equal semi-annual payments in an account that pays this much interest. So the question is asking, find the amount of each payment. Right. So let's check the diagram here. So let's check the time diagram. So today is period 0. So the company, they need so the company, they need how much amount of money? They need $100,000 8 years from now. So they need $100,000 8 years from now. So they need $100,000 8 years from now. So 8 years from now, right? So to achieve these amount, to save these amount of money, they were making equal semi-annual payments. So they are making equal semi-annual payments. They are making equal semi-annual payments. So equal semi-annual payments means, semi-annual means at the end of 6 months. So that means at the end of every 6 months period, at the end of every 6 months period, they are making some payment. So that is the first payment. This is the second payment. This is the third payment. And like that way, in 8 years, in 1 year, semi-annual payment. So in 1 year, you will gonna have 2 payments, right? So semi-annual payments means, at the end of every 6 months period, they will pay 1 installment. At the end of 1 year, by that time they will pay 2 installments. So that means in 1 year they will pay 2 installment. So in 8 years, so in 8 years they will make 8 multiplied by 2. In 1 year they will make 2 installment, or they will make 2 payments. So in 8 years they will make total 16 payments, or 16 installments, right? So that means future value of these all savings. So future value of all these savings should be $100,000. So future value is given. We need to find out the value of C. That means the question is asking how much should you deposit at the end of each semi-annual period. So future, we know the future value. So that means we know the future value. So future value is, we know future value is equal to, so future value of annuity. So this is annuity, there is no doubt about that. This is annuity, and future value of this annuity we already know. So future value of this annuity we already know. That's why we will use the future value of annuity formula. That's why we will use the future value of annuity formula, and the formula is this one. So this is the future value of annuity formula. So now we need to find out the value of C. So to find out the value of C, what we can do? We can do the cross multiplication. So if you do the cross multiplication, we will have these one. So right, so now we can put the values there. So future value, we want to accumulate $100,000. We want to accumulate $100,000 in 8 years, or after 8 years. So R, rate of interest 7%. This is the annual rate, but interest will be compounded on a semi-annual basis. So 0.07 is the annual rate. 7% means 0.07, but it will be compounded on a semi-annual basis. That means after every 6 months. So we have, in 1 year we have 2 semi-annual periods. So divided by 2 to find out the semi-annual interest rate. This is the annual interest rate. To find out, we need to find out the semi-annual interest rate. That means interest rate after every 6 months. So we will divide it by, in 1 year we have 2 semi-annual periods. So we divide it by 2 to find out the semi-annual rate. And then C, 1 plus R. So R is 0.07 divided by 2. R is 0.07 divided by 2, bracket power T. So power T is equal to, we know that power T is, in 8 years we have total 16 payments. So power is 16 minus 1. Right. So now let us do this calculation first. So let us do this calculation first. So if you do this calculation, how much will you get? So you should get 3,500. You should get 3,500 here. So 3,500 is equal to here we get what? So C. So here in the right hand side we get C multiplied by. So let us do this calculation. Let us do this calculation. So we will have is 0.7339, right? 0.7339. So right, so C will be what? C will be equal to 3,500 divided by this one. So 3,500 divided by these one. So 3,500 divided by this one, we have just calculated it. So this is already in the answer. So I can, to get the more accurate result, I can just press the answer button there. So divided by answer. So 3,500 divided by answer. So we should get this one. But if you get slightly higher or lower, it doesn't really matter. So this is the semi-annual installment. So that means if the company save $4,768.483 at the end of each semi-annual period up to 8 years. After 8 years they will have $100,000 in their account. After 8 years they will have $100,000 in their account. Right. So now let us solve this question. So what we have in this question, a $70,000 condominium is to be purchased by paying $10,000 in cash. So that means the apartment or the flat or the condominium price is $70,000. So the condominium or the apartment price is $70,000. And you want to purchase it, you have paid $10,000 cash, and the remaining $60,000 you have paid by a mortgage loan. So remaining $60,000 you have already paid by getting a mortgage loan, and the maturity of the mortgage loan is 30 years. That means $60,000 you have paid by borrowing. So this $60,000 you have paid by borrowing through a mortgage loan, and you need to pay off the loan. That is, you need to pay off $60,000 by 30 years, and this is the interest rate. Question is asking find the monthly payment on the mortgage. Question is asking find the monthly payment. That means how much you need to pay at the end of each month to pay off the loan or clear the loan. So that means how much monthly payment means how much you should pay at the end of each month to clear the loan or pay off the loan. So let us check the time diagram. In the exam you don't need to show me the time diagram, but if you draw the time diagram, it might help you. So today you have borrowed $60,000. So today you have borrowed $60,000, and you will gonna pay off this loan by making equal monthly payment. So that means at the end of 1 month you will make C amount of payment, at the end of 2 months you will make C amount of payment, at the end of 3 months you will make C amount of payment. These are the installments, monthly installments, and like that way this is a 30 years maturity loan. So that you will pay off this loan. You have borrowed this $60,000 and you will pay off this loan by making equal monthly payments. So this is a 30 years maturity loan. So 30 years means in 1 year we will have total 12 payments. So in 30 years we will gonna have total 36 payments. So in 30 years we will have total 36 payments or installments. Installments. So that means the last installments, sorry, 360. So the last installment will be 360 months. So that means after 360 months you will be able to pay off the loan. So that means after 360 months you will be able to pay off the loan. So that means the present value of all these future cash flows, so present values of all these future cash flows should be equivalent to $60,000. So that means this $60,000 you have borrowed today. So this is the present value of all these future cash flows, right? So that means $60,000 is the present value of annuity. So this is here, this is annuity, and present value of annuity is $60,000, right? So $60,000 is the present value of annuity. So present value of annuity we know, we have the present value of annuity. So that's why we should use the present value formula, present value of annuity formula. So present value of annuity formula is C divided by R bracket 1 minus 1 plus R power. In the present value formula, power should always be minus T, right? So this should be the formula, right? So as usual we will do cross multiplication. So if you do cross multiplication, we will gonna have this one, and then what we will gonna have, so P, so present value of annuity is $60,000. This is the amount you have borrowed. So $60,000 is the amount you have borrowed, multiplied by R, rate of interest rate. So rate of return or interest rate. Interest rate is 9.75% is the annual rate. We need to get the decimal of this. So 9% means 0.09. 9% means 0.09, and 9.75 means we need to get 75 after that. So divided by compounded monthly. This is the annual rate. So compounded monthly means we need to get the monthly interest rate. So we will divide it by 12 is equal to C, and then 1 minus 1 plus R. So this is the value of R. This is the value of R, bracket close, power minus T. So T is, we have total 36 installments, 36 periods, 36 months. So 360. So now first of all we will multiply these two. So first of all we will multiply these two. So let us multiply these two and get the figure. So 60,000 multiplied by 0.0975 divided by 12. So 60,000 multiplied by 0.0975 divided by 12, we should get 487.5. We should get 487.5 is equal to C multiplied by, now let us calculate this one. If you type it exactly like that way using all the brackets, so that means 1 minus bracket 1 plus 0.0975 divided by 12. If you close the bracket and get power, so power is minus 360. So you should get this one, 0.9456 or 0.94569, right? So C will be what then? C will be equal to 487.5 divided by this one, Right, so this one we have just calculated it. It's already in the answer. So what we can do, we can just press 487.5 divided by answer button. So to get the more accurate result. So the answer is $515, $515.4926. So $515.4926. So these will be the monthly installment. So that means you have to pay $515.4926 at the end of each month. To pay off the $60,000 mortgage loan. So you need to pay $515.496 at the end of each month, and like that way up to 30 years to pay off the mortgage loan amount of $60,000. Right. Now the second question. The second question is asking what will be the total amount of interest paid. So total amount of interest paid. First of all, we need to find out how much in total we are paying. So first of all, we need to find out how much in total we are paying. So we are paying total 360 installments. So we need to pay total 360 installment over the 30 years period. Right. And each installment is this one. We have already calculated it. So this is if you multiply this one, you will get the total amount you will need to pay. And minus, if you deduct $60,000 from that one, you will get the total amount of interest you actually paid. You need to pay. So total amount of interest you need to pay, you can get it. So multiplied by 515.4926 minus $60,000. So that means the answer will be 577.336. So this is the total amount of interest you will need to pay for 30 years loan. So $125,577.336. That's the total amount of interest you need to pay. Right. Now the third question. Show amortization schedule for the first two payments. Remember, bank will, so when you gonna make your first payments, bank will, let me show you the amortization schedule. This is the amortization schedule. So at the time the first payment is due. So that means after 1 month, when you gonna make your first payment of $515, so this is the monthly installment you will gonna pay. So at the end of 1 month, when you will go for first installment, or when you will want to pay your first installment, by that time 1 month is over. So what the bank will do, bank will calculate interest amount for that 1 month. So that means I'm repeating again. So at the end of 1 month, when you will go for first payment or first installment, by that time 1 month is over. So because of that, bank will first calculate the interest amount for that 1 month. So $60,000 is the amount you have borrowed, and this is the monthly interest rate. 9.75% is the annual rate. If you divide it by 12, this is the monthly rate. So that means this is the 1 month interest rate. So this is the total amount you have borrowed, right? So that means for the first month, this is the interest amount, right? So after 1 month, when you go for first payment of $515, bank calculated that $487.5 is the interest amount for that 1 month, for the first month. So bank will deduct this amount from the amount of payment. So this is the amount you are paying. So from that amount, they will deduct the interest amount, right? So that means from this one we will deduct this one. So remaining amount will be adjusted from the loan balance. So remaining amount, this is the remaining amount, these will be adjusted from the loan balance. So initial loan balance is $60,000. So from that one, these $27.99 will be deducted. So that means you actually paid, you actually pay off $27.99 loan. So that means you have actually, so this is the amount of interest you have paid, and this is the amount of dollar you have paid off the loan. So this is the loan balance will reduce by this one. So these will be the new loan balance after first month. At the end of second month, when you will go for your second payment or second installment of same $515, bank will calculate interest amount for the second month. Bank will calculate the interest amount for the second month. So this is the monthly interest rate, and for the second month, this is the loan amount. This is the loan balance. So for the second month, this is the loan balance. So interest will be calculated on the loan balance. So this is the new loan balance, and interest, this is the monthly interest rate. So if you multiply, this is the amount of interest you need to pay for the second month, right? And you have already paid this much amount. So from these one, if you deduct these one, you will get $28.22. So this is the amount loan balance will be adjusted. So loan balance will be reduced by this one. So that means out of this $515.49, $487.27 is the interest amount, and this is the amount you have paid off the loan amount. So that means previous loan balance was this one, and from that one you have paid $28.22. That means this, from previous loan balance, this one will be deducted to get the new loan balance. So after second month, your loan balance is $59,943.8. So this is your new loan balance. You may think that you have already paid two installment. That means you have already paid approximately $1,031. But according to bank, you have only paid off this much amount. You have only paid off the loan. You have only cleared the loan this much amount. That means approximately $56. So approximately $56 you have cleared the loan, right? So this way amortization schedule will be calculated for all the 360 months. So this way in amortization schedule will be calculated for all the 360 months or all the 360 installment, right? So but in the exam you will be asked only to calculate amortization schedule for the first two payments only. So that's the end of today's lecture. In our next lecture, we will study annuity due problems. We will study some advanced annuity problems, and then we will go for multi-step problem, right? So that's the end of lecture 3, time value of money lecture series part 3.